All right, let's dive into a little digital mystery today. We are putting on our detective hats and going deep behind the scenes of a server. We're going to find out exactly what happens when you ask it to find your events. Think about it. You're on a website, you click My Events. It's something we do all the time, right? But that one simple click, it kicks off this lightning fast data retrieval mission. So, what is actually happening in those few milliseconds between your click and that list of events just popping up on your screen? So, here's our game plan for this whole investigation. First, we'll lay out the mission. Then, we'll check out the high-tech toolkit our system is using. We'll follow a request on its four-step journey, then peek inside the code's logic. We'll even see what happens when things go wrong, and finally, wrap up with why this whole thing is just so darn efficient. Okay, first things first, we have to understand the mission. The main goal of the function we're looking at is, well, it's pretty simple, but it is absolutely critical. The mission, should our code choose to accept it, is to find every single event tied to a specific organizer. But it's not just about finding the data. It has to grab it, clean it up, and deliver it back in this perfectly structured format that the app can use instantly. You can think of it like a super fast digital librarian for your calendar. Now, you know, every good detective needs a toolkit, right? And in the world of the cloud, our detective has some seriously powerful services at its disposal. Let's meet the two stars of the show. First up, we've got AWS Lambda. This is the brains of the whole operation. It's what we call a serverless service, which is a cool way of saying we don't need a computer that's on 24/7. Nope, this thing just springs into action the moment a request comes in, does its job, and then goes right back to sleep. Incredibly efficient. And if Lambda is the brains, then Amazon DynamoDB is the archive. This is our massive records room. It's a super high-performance database that holds all the event data. And it's meticulously organized so our Lambda function can zip in, find exactly what it needs, and get out in a fraction of a second. Okay, so we've got our mission and our toolkit. Now let's actually follow a single request from start to finish. We're going to trace its journey step by step, from the moment you click to the final result. You know, it's actually this beautiful, simple four-step dance. First, your click acts as the trigger, waking up our Lambda function. Second, the function zooms over to retrieve the data from our DynamoDB archive. Third, it has to format all that raw data into a nice, clean list. And finally, step 4, it will return that tidy list as the response. Trigger, retrieve, format, return. Simple. Now for the fun part. Let's pop the hood and look at the actual code that makes all this happen. We're going to meet the specific functions. These are our detectives on the ground, the ones doing the real work. So, everything kicks off with a function called the lambda_handler. I want you to think of this as the dispatcher at the police station. When a call comes in, this is the function that answers, figures out what's needed, and passes the case file to the right person. That dispatcher then hands the case over to our case manager, a function called getOrganizerEvents. Its job is to oversee the whole investigation. It pulls out the most important clue, the organizer's email, and then coordinates the entire operation. And here's our lead investigator, getEventList. This function does the real legwork. It takes that organizer's email, marches right into the DynamoDB archive, and queries the database to pull out every single matching event record. This is where the heavy lifting happens. So, how does it do it so fast? Well, here is the system's secret weapon, a global secondary index, or GSI. Okay, think of it this way. If the database is a gigantic book, trying to find everything by one author would take forever. The GSI is like a special index in the back of the book, already organized by author, so our investigator can just flip to that index and find the right records instantly. It's a total game changer for speed. Once our investigator has all the raw data, it gets handed off to the report writer, format events. This function's job is to take all that database gobbledygook and turn it into a clean, easy-to-read report. It uses a format called JSON, which is just a standard way to organize data with fields like start time, end time, and summary, all ready to be sent back. But how does our team of functions know where to work or what the rules of engagement are? Through these things called environmental variables. They're basically a set of standing orders that configure everything: which server region to operate in, the name of the database table to search, even how many events to return at once. But you know, what happens when an investigation hits a dead end? A really great system isn't one that never makes a mistake. It's one that knows how to handle failure gracefully. So let's look at two possible outcomes here. On the left, everything goes perfectly. We get a success code, an HTTP 200, and the list of events. But on the right, what if the organizer's email was missing? The system doesn't just crash and burn. No way. It intelligently responds with a not found error, an HTTP 404, and it makes a note of the problem so a developer can look at it later. And it's ready for other problems too, like if the database is temporarily down or some other totally unexpected error pops up. In every case, the protocol is the same. Log the issue for the humans to fix and send back a clean error message without bringing the whole service down. It's incredibly resilient. So when you put all these pieces together, what you get is a system that is truly and beautifully efficient by design. The big takeaway here is that by using the pay-as-you-go power of AWS Lambda and the incredible speed of DynamoDB with its secret weapon, the GSI, you get this streamlined, robust, and super efficient way to retrieve an organizer's entire event history. And that kind of leads us to one last big idea. This whole setup is amazingly efficient for just one person's request. But what's truly mind-blowing, and maybe a story for another time, is how this exact same design allows the system to scale almost infinitely, handling requests from 10, 1,000, or even millions of users just as easily. Now that is cool.